Hello, Apidays Helsinki here, and I have a visitor from another country. Are you in Germany right now? Where are you?
I'm in Vancouver, Canada.
Vancouver, Canada. Okay, couldn't
Good
fool
morning.
me. So yeah, it's evening in Finland and morning in Canada, so that's perfect. And you have something to share about this remote time that we are all living. What did you have in mind?
Well, so as a first, like this unprecedented time, as we all now go through a massive change in our way we think, experience the world, experience our community. And you particularly asked in the email to say something positive, like the silver lining.
Yes.
I appreciate that. And what I observe here in my neighborhood is that many more people now experience the livelihood of the street. I go around with cameras, take a little bit more time to observe details. And also that now more and more people bicycle around the city. And the city has started to actually close some roads for vehicles and make them to big bicycle highways. And so now more and more people go to these parks with bicycles. And there's now an active discussion whether some of these bicycle lanes that were now established actually should also be implemented post-COVID. And to the extent that bicycling so far here in Vancouver has been often associated with a risky, dangerous activity, and now more and more people enjoy it, and to the extent that Vancouver wants to be one of the greenest cities in the world, that might be a really good chance to move the city forward to a higher quality of life environment. So that is one of the lessons that I personally enjoy observing here.
That is a very European thing to happen in Canada.
Oh, you're on mute, so I don't hear you right now.
Yes, realize that this had come automatic. Need to cut that. But yeah, I think that it has been interesting to see that from all the speakers so far that there has been this idea of local and communities and kind of a totally different values of life in a way, becoming the norm.
Right.
But hey, so from all of that green and outdoors thinking, we are going to a very a different kind of open situation here. So open data architecture, not like open bicycle architecture, but data architecture. And you are going to tell us about more traffic stuff and open data. So good, go ahead, Hendrik.
Right. Okay. So yeah, today I will present work in progress on the open data architecture for mobility as a service, or in short, MaaS industry. And just as a quick background, I'm professor of economics at Fraser University, and I'm director of the small think tank selfdrivingcities.com, working with students on questions of how do new technologies in the transportation sector, these new platforms that you guys, I assume the audience is mostly programmers for APIs and apps. If that is correct, then probably some of you have been looking into the platforms that are programmed for some of the companies that are in the MaaS, so in the mobility as a service industry, for example, Lyft, Uber, shared bicycle companies, shared scooter companies, or even aggregator apps such as Google Maps, Transit, City Mapper. These are all new technologies out there that are now more accessible to everyone because everyone is working around with cell phones. And these create incredible new opportunities for the transportation sector as a whole. And for me as an economist, I'm interested how these new technologies affect a bunch of economic outcomes, such as air quality in the city, real estate prices, business life, how does it shift, congestion, and so on and so forth. but importantly, how mobility as a service, and in the future, AV stands for autonomous vehicles, so basically that's a computer on wheels, how do these new devices will affect, improve, or deteriorate our way how we commute and our cities, crucially depends on what kind of policies and regulations jurisdictions are putting in place. So a lot of our work in the Institute is to look how these policies affect then economic outcomes, but also how these policies affect the market structure of the mobility as a service industry itself. Out of our work then come a lot of policy recommendations, and for the purpose of today's talks, I will focus purely on the policy recommendations that come out, how the new data architecture could or should be designed in order to have an economic outcome and a welfare distribution that is good for both the companies, but also the consumer and the government, the whole society as a whole. As an economist, we always want to maximize the welfare function for the whole society and not work in the interest of one particular company, but typically we want to create like a competitive environment where companies work for the overall good of the society. So quickly as background, what is MaaS? What is mobility as a service? Shortly said, but basically all the devices that you do not own yourself, but that you rent for a particular trip, right? So the bus, train, the shared cars, the Uber and Lyfts out there, the docked bicycle stations that you now see over many cities, the dockless bicycles, and then recently Uber acquired the company Jump, which is an electric bicycle company. You can rent these devices and go throughout your town. The MaaS now goes forward into the micromobility. That is a term for these new fun devices that you can also rent via apps. We observe in that industry a massive takeoff. Right? So this is already old data by 2018, but you see all of these platforms are enjoying increased user base, and there are predictions out there that by the year 2030, the market share in some of the cities of trips taken by MaaS devices will be 50% or so in certain areas of all trips taken overall compared to the private vehicles. What we also observe in that industry, that there is a massive market concentration going on. So just to give a couple of examples here from the US, Lyft meanwhile owns 80% of all bike share rides in the US because they acquired the bike share company Motivate. So Lyft is not only a ride-hailing company, it's also more like a company that wants to go like being an Amazon for urban transportation, where they also offer in the future transit tickets, where they offer bicycles, scooter rides, and also ride-hailing. Uber is going in the exactly same direction. They also try to be the Amazon for urban transportation. And then third, Mercedes-Benz with Car2Go, they had the merger later on with BMW on their program on Reach Now. They also tried to compete in that space. In North America, they could not, so they fell out. So basically what we see in this industry is a massive market concentration towards 1-2 companies that are left within a city. And we study the economics around it, and John Tirole, who got the Nobel Prize for some of these ideas applied to social network platforms, has a great model that you can also apply to the MaaS industry. So basically you guys are programming here this platform like Uber and Lyft, and then the more drivers are out there, the less is a waiting time for the rider, or the more riders are out there, the less is a dead heading. So basically a taxi driver or ride-hailing driver driving empty around in the city, the lower are the marginal cost and the higher is the probability of actually finding pooled rides that lowers further the marginal cost of each trip and actually increases the environmental quality of the trip itself. So these are the reasons, these positive indirect network effects are the reasons why these platforms tend to monopolize. In economics, we make a distinction between a monopoly and a walled garden. A monopoly is one company that offers one product. So for example, Uber just offering ride-hailing. Walled garden in comparison is a monopoly that offers multiple services. So now Uber also offering electric bicycles plus scooters, Uber scooters, is now offering multiple services. And from a city perspective, or first, let me back up, from a consumer perspective, at first glance, that may seem as a very positive development, because the consumer only needs to open one app and then you can see all transportation options on this one device instead of flipping through 15 different apps. You don't need to do that anymore because this one walled garden offers everything. But from a city perspective, there are several concerns. First, data policy. There are reports that if you get consistently bad ratings on Lyft or Uber, then actually Uber, these companies can close your account. So in the Corona epidemic in Mexico, 2 months ago, there were reports that Uber closed a couple hundred accounts of Uber users because they were connected to some Corona case. But that is then a problem for the city if public transportation relies on just one company, and then we are subject to their data policy. The second risk is pricing. So economists all agree on that a walled garden in particular, but also a monopoly, is always in the long run offering the product at a lower quality to a higher price compared to a competitive market. So me as an economist, I want to think about how can we push the mobility as a service industry into an area where we have more competition going on instead of this walled garden, and what kind of new data architecture can we prescribe that will allow that. The third risk for the city of a walled garden is strategic behavior. So assume outside of your office building there is a jump bike by Uber, but an Uber driver may not have had a ride for the last 10 minutes. So there is a concern that then such a company may display the more valuable option for them to you on your app and not display the other. This is strategic behavior that walled gardens can potentially engage to. I don't say that Uber is doing that or Lyft is doing that, but there is a risk at walled gardens in general that they can discriminate different services in such a way to their own advantage, especially if there's a lack of other competitors around. And finally, a walled garden has the disadvantage that the technology is potentially locked in an inferior equilibrium. So let's say Mayuka, who did the kind introduction here this morning for me, that Mayuka invented a new electric bicycle that is actually better from the standard than the jump bike. But Mayuka doesn't have millions of dollars. She only has a couple thousand that she got. So she may put 100 bicycles into the city. The problem is nobody will open the Mayuka app because it's just the market share is too small. What if we had a data architecture where we had an aggregator app such as Google Maps or Expedia for urban transportation or transit or Citymap or whatever you want to call them, who is allowed to display all mobility options? Then actually the Mayuka bike would also be displayed there if people use the aggregator app. And if the Mayuka bike is truly of a better quality than the competitor, then actually people may be able to walk like 1 or 2 blocks more to get that bicycle. And so slowly the market share of a superior technology actually takes place instead of a walled garden where those competitions are not possible. So in a sense, because of this market monopolization that we observe in the mobility as a service industry, our aim here, for me as an economist, is to think about antitrust policy options that will break up this network effects and in such a way that it's still good for the consumers, but also good to have more competition out there in that space so we don't get into a walled garden situation. And I already now displayed for you what is the baseline scenario, the unregulated market. That's the John Tirole model where you get these strong network effects. And basically, in the rest of the talk, I will briefly go through these 4 other policy options that are out there that some of the cities already are implementing as antitrust policies in the new mobility industry. And our favorite one is the mid-layer API mid-layer approach as a public utility, and I want to explain that next. So first of all, let me describe a little bit the market structure in that mobility as a service space. So first of all, you have the operators, which are Uber, Lime, Lyft, your local public transportation provider, and so forth. But all of these operators basically want to be the Amazon for urban transportation, right? So Uber will try to kind of like integrate all other mobility options into their platform and monopolize the market. On the other hand, you have these aggregator apps, such as Google Maps, Expedia for urban transportation, and so on. Whim is one here in Helsinki. And these aggregator apps, they want to, they are forming contracts with the operators in getting their data. And in fact, until 2017, it was the case that the operators actually were quite willing to share some of the data with the aggregator apps. And so basically what you were observing that there was a competition out there among operators and a competition among aggregator apps as well. But then something shifted in 2017, 2018. At that point, the operators actually understood better the value of their own data. And instead of giving the data to the aggregators, many of these companies decided, no, I want that the end user only operates on our app only and doesn't book us through third-party applications. What Finland has done is quite interesting. That was the first country to say that this data is so valuable, especially also for the aggregator space, that it's also so beneficial for the end consumer to see everything in one platform, that all the operators that are operating in Helsinki or in Finland have to share, mandatory. It's a mandatory policy that they have to share the data with aggregator apps. The remaining problem then was, many problems, but like one of the remaining problems was that if all the aggregators now are hitting the servers of all the operator companies, then basically the operator companies want to start charging some money for that access because literally their servers run hot. In addition to the aggregators that want to get all the information from the operators itself want to get all the information from their competitors. So there's a massive amount so these devices move this all in real time. and everyone wants to know where to place the bicycles as a function of other companies, strategic behavior. And so strategically, the companies then try to cut off the links to the other ones. And so because there is a cost for these operators to provide that data to aggregators, most of the operators decided not to share the data anymore. And if so, at a very, very high cost. What we did here in British Columbia, so I'm here in Vancouver, Canada, is to create an in-between governmental run mid-layer. It's called the API mid-layer, or borrowed from the airline industry, the computer reservation system. This has the advantage that the API mid-layer is now scanning all the devices about every 2 to 5 seconds, depending if it's like a Friday busy night to avoid overbookings, then it's every 2 minutes. If it's in the middle of a night on a Tuesday, maybe every 5 to every 10 seconds is enough to avoid multiple bookings. But in a sense, this computer reservation system is scanning all the devices only once every couple of seconds, and then the public utility is selling that data to the aggregator space. And that's actually quite similar to what's also happening in the electricity market. So this is a new data architecture that jurisdictions are thinking about, and that I, as an economist, I'm studying the welfare implications. And basically with this data architecture, we see a number of benefits. So first, in a healthy, competitive aggregator space, everyone has a possibility to see all mobility options in one app. Second, small suppliers can compete. Yeah, so Mayuka's bicycle could actually be shown there. Competition leads to lower transportation prices. It ensures that always the most innovative product is at the market. We no longer have the walled garden strategic behavior problem, and we actually get a competitive market on both sides, the operator space and the aggregator space. In addition, then the mid-layer sets the price for the aggregators, and the mid-layer also, move this around a little bit on my screen, can use this data for research, urban planning, and other third-party applications such as congestion pricing in cities and carbon offsets. You could also imagine a situation where this API mid-layer public utility is not only selling the data to the aggregator space, but maybe selling it at different prices. For example, a city may want that electric vehicles have an incentive to be displayed with a larger icon on the API, on your app, compared to a brown SUV ride, or that the electric rides are displayed or are sold at a lower price to the aggregator space, or even given for free to the aggregator space, and then brown rides are charged a higher price. So there are many ways how the API mid-layer, this computer reservation system, can now manage the data. And as we know, this data is gold in that industry, and make it really to the best use for the society, and creating both a competitive operator space and a competitive aggregator space. Maybe for this audience, just very quickly, what would be the data requirements? Of course, like you need the location of all available devices out there, the vehicle type, the pricing matrix, battery fuel level, some of the details. Some regulatory steps. You need to prevent malicious compliance, such as a company may display only the Y-class ticket, like in the airline industry, to the aggregator space and then have cheaper S-Class tickets on their own app. So you have to kind of prevent that there is this differentiation going on, so that really all mobility options are displayed to the aggregator space and not only a subset. There are certain data formats out there, but maybe that goes too much into the details. Okay, if I have some minutes left, then I would like to compare this open data, like by law open data policy, with the policy options that are currently used in the mobility as a service industry. First is exclusive contracts with one aggregator. So cities are often aggregating that data to one white label aggregator that the city is running. The advantage of that is that the city has full control of what is displayed. The disadvantage is that there's no competitive aggregator space, and then also less incentives to innovate, right? So, for example, my father, he is 92 years old. He has a cell phone, but he wants to have an aggregator likely that is very simple to use. Whereas my daughter probably can handle an aggregator app where she can triple click and wipe to the left and right. And so it's good to have market differentiation also in the aggregator space and not only one aggregator out there. And also another disadvantage of having exclusive contract is that it relies on bilateral contracts with operators and single point of failure, right? So the reason why I put in 2 API mid-layer boxes is because if one fails, like do a blackout, then at least the other is still running. And that is important because these operators, including your public transportation system, is an essential service, right? If you have to go to the hospital at 3 a.m. in the morning, you better make sure that this API mid layer is running in real time and has an appropriate bandwidth. So another way as an antitrust policy that cities have been implemented in this industry is supply caps. The supply caps basically function that, okay, Uber gets 10,000 vehicles, Lyft gets 5,000 vehicles, Lime gets so and so many devices, and these are pretty much fixed. Sometimes you can buy and sell these shares. We basically all know that from the taxi industry. In the taxi industry in the 1920s, 1930s, in New York City during the Great Recession, more and more immigrants came and became taxi drivers. And then the Taxi Driver Association itself actually lobbied to have a cap on the amount of taxi drivers because they were putting their themselves out of business by having too many taxi drivers out there. So they lobbied to have a license model, a medallion system, where, and then the government said, well, that's actually a good idea. For every taxi now needs a $10 taxi license. But then as soon as the economy took off, then one good taxi driver said, oh, okay, can I buy your taxi driver license for $20? And then the next one for $50 and then $100. And so the price went up and up and up in New York City, up to 1.3 million until 2011 when Uber came into New York and that whole thing crashed to about 10% of the value. So these kind of caps are now also discussed for the ride-hailing and mobility as a service industry in general, but we know that these shadow prices really put like a large burden onto the industry itself. And it's very hard once you have such a system in place. We also know that from agriculture, like milk quotas, and many other industries, once you have these rent seeking in place, it's very hard to get rid of them. So we don't want to repeat these historical mistakes now in the new mobility as a service industry. So instead of having supply caps, we as an economist and in our self-driving cities institute together with BC government and TransLink, which is our local provider. We are thinking very hard about this new data architecture. And it actually just got implemented on the legislative side. The BC is the first jurisdiction in North America to aggressively demand open data from all operators. The advantages, again, are free competition produces innovation, quality improvements, and lower price for the consumer. And so we can protect competition by promoting an open data. And creating a computer reservation system as a public utility creates additional benefits of lower data transfer costs between the aggregator space and the operators. And the data in the end can be used for public needs, the opportunity to collect additional data for regulation, research, carbon offsets, congestion pricing, and many other applications, advertisement. Okay, with that, I conclude and looking forward to the discussion. Thank you.
I had to change my background picture to include that bike that my app is providing you. But so this is Helsinki and the city bikes there. But I have so many questions. But the first question is that I was involved in the Finnish legal renewal where the law that requires all the public transportation operators to open the APIs or open interfaces actually to each other, but there was only like a set of open data. Well, the most important stuff, of course, the traffics and everything. So how do you see that in terms of there's already a law saying that, hey, all these aggregators can use your APIs and you can use your APIs too. So should that law be changed now? I mean, to enable that kind of public data hub kind of infrastructure, or is it even a data hub? Is it just integration pipeline, more or less, that you described there?
Yeah, so basically we got inspired here in British Columbia by the Finnish model. And looking at the Finnish model, we see, as you say, there are only a handful, I don't know the exact numbers, you know that better, operators that are participating, and some other operators are not sharing the data.
Yeah.
And
not as openly. Yeah.
So in a sense, the legislation does not have enough bite. Where some of the big operators just simply say, no, we don't have an open API, or they want to charge extreme high costs per data request. And that was then the reason to think, okay, how can we modify the Finnish model in a way that the data transfer between the operator space and the aggregator space works more smoothly. And there are basically two pieces to it. One is from a regulation point of view. In British Columbia, they wrote into the license agreement of every operator, so for the ride-hailing industry. And BC is an interesting case because we did not have Uber and Lyft until January of this year. And so because we came in so late, people complained a lot that why is there no ride-hailing? But the silver lining was that the government, together with researchers like me and other stakeholders, could really think about how should the legislation look like that governs the ride-hailing industry. And one of the crucial pieces that was written into the BC regulation is that, in principle, the government can request the real-time data from all the operators. And if the operators want to come to Vancouver or want to come to British Columbia, then they have to be subject to that regulation. And if they do not participate, then they lose their business license. So it's a much harder, stringent approach in British Columbia, where it's directly written in each business license agreement with each company. That's the first piece. And then the second piece is that the public utility as a mid-layer scans all the devices every 2 to 5 seconds in your city. And then the public utility is then selling that data to the aggregator space. So there's a constant pipeline between the operators and the aggregators. It doesn't work that way yet in British Columbia, but that is the model that is thought through how it could work in the future. And one of the advantages is that this public utility as a mid-layer, the board of the directors of that one would be people from the Ministry of Transportation, would be from the TransLink, which is our local public transportation operator, academics, and other interest groups would be in that mid-layer, and they can then discuss how the data should be sold to the aggregator space, and also what should be displayed in what way. Because like if you have hundreds of companies and not only one or two like Uber and Lyft, but if you have literally hundreds of companies, including the awesome Mayuka bicycle, then which icon do you display bigger? Which icon do you display? How do you make a fair, how do you manage that? And all that can be discussed and made operational on the mid-layer level instead of...
I kind of totally agree, because actually what has happened even in Finland is that there is this traffic management Finland who they are basically doing this data hub and APIs and real-time APIs on some of the traffic data, not the kind of public transportation as it is, because there's that law that says you can connect directly. But then there is actually Business Finland, Visit Finland, Kaisa Kosonen is actually presenting in Apidays Helsinki this year, this travel data related data hub, where exactly that same thing is applied to travel data. And then also I'm just working now with a lot of Finnish communities and Business Finland and the Ministry of Transportation, that there's a plan of how to actually come up with the cities and municipalities that they could actually build these kind of real-time data hubs, or like even store the data for longer time use for themselves, because they are kind of, there's the problem for service traffic, social, healthcare related, and education, like basically taking children to school and hobbies and stuff, especially in the remote areas where you don't have that much of like traditional public traffic, and they have special needs and everything. So to take that model that you actually basically presented, we have similar drawings here too, but there you can actually demand a little bit more, even if it's not the law, but you can basically say that there's no space for you in our city or in our municipality. We don't buy the service from you unless you let us do this real-time integration. And there's just a kind of a twist for this that we are planning, that it's not so much that all the traffic would be going through these kind of pipelines or API layer, but more that the APIs that are already required by the law would be kind of repurposed a little bit. They would be kind of catching the data mid-air, so to speak, but not directly being the hub between. But that's also an option. So it's interesting to see where you are going with this, exactly for those reasons, the same reasons that you presented here. But hey, thank you. And we have lots of platforms and data hubs and other topics coming in Apidays Helsinki. So, and even some more mobility things. So thank you for your presentation. And it was a real pleasure that you got the time early morning to talk to us.
Thank you for having me, and looking forward for other questions and the rest of the conference.
Exactly. Thank you.